So chapter 8, we are starting something brand new today, kind of deviating away from the logs and exponentials. And we're working our way back to something that we did at the beginning of the year, actually, which is factoring. So it's not that factoring is the main part of this stuff. The goal is actually something completely different, but it's assumed that you know how to factor in order to do all of those things. So as I'm going through and doing some of these examples, we'll make sure we'll recap on some of our factoring skills. So the first thing that we're going to do, this whole chapter is all about rational functions. And we're first going to define what exactly it means to be rational. But the first thing we're doing today is simplifying rational expressions. And then we're going to move into multiplying and dividing. And then in future sections, we'll be adding and subtracting and graphing and doing all sorts of other fancy things. The first thing I want to do is define it. What is a rational expression? A rational expression is a ratio of two polynomial expressions. Okay, so I purposely use that word ratio in the definition because when you see rational, I want you to think ratio. So rational numbers, remember, were just a ratio of two numbers, like 2 over 3 or 1 over 7 or something like that. So a rational expression is basically just a ratio of two expressions. And you can see throughout the rest of the page, we've got lots of examples of exactly what a rational expression looks like. So when you're reducing fractions, picture a fraction like 4 over 6. 4 over 6 both have a 2 in common, and so you cancel out that common 2, and that's how you reduce just a normal rational number. The techniques are basically the same for these rational expressions. There's just one little thing you need to do first, and that is factoring. So like I said, it's kind of assumed that you know how to factor when you're doing all of these. So let's recap some of those real quick. So let me run you guys through. For this first one, I'm going to give you a step-by-step of exactly how to work through all of these. So your first step when you are simplifying rational expressions is to factor everything. Factor the numerator, factor the denominator. Every single piece that looks like it could be factored, you're going to factor it. So we're going to do that. We're going to take a look up at the numerator. So the numerator, everything's pretty much broken down into pieces. So I'm just going to rewrite those pieces. So 4y, I've got a y minus 3, I've got a y plus 4, there's nothing really that we need to do there. And then if you look down in the denominator, the big piece in parentheses, I do need to factor that. Okay, so the y stays right there. And then this y squared minus y minus 6, I know it's going to get factored down into two different groups, so I can start there. And then for the y squared, I'm going to have a y times y. And then remember when you're doing this form of factoring, you're looking at these two numbers right here. We're trying to figure out what will multiply to a negative 6 and also add to a negative 1. And so that would be a negative 3 and a positive 2. And can you always double check, refoil them out, make sure you come up with the same thing. But again, I picked these two numbers because they multiplied to a negative 6. Negative 3 times positive 2 is in fact a negative 6. But also when I add them up, which is the outside and inside term, I get a negative 1. So a negative 3y and a positive 2y give me a negative 1. Okay, that's my first step. Anything I can factor it down. Step number 2 is I'm going to eliminate common factors. Okay, so any factors that are common, I'm just going to cancel them out. All right, so if we look, see the y minus 3's. Y minus 3 over y minus 3 ends up producing just like 1 over 1, and I don't have to write that. And then I also have a common y. I have a y right here and a y right here, so I can cancel those out. Now let me point something out to you that's going to seem very tempting. When I see these two pieces right here, people love to just try to cancel those y's out. You can't do that. Whenever you have something written in parentheses like a y plus 4, it's a package deal. Unless you can cancel it with another y plus 4, you can't cancel it at all. So you can't cancel this y with this y. The only reason you could cancel this y with this y was because it was kind of a free agent of a y. This y is attached to a 4, this y is attached to a 2. So unless you find another y that's attached to a 4 or another y that's attached to a 2, you cannot cancel. Okay, third step is to simplify. Simplify it up, kind of rewrite everything nice and neat. So in the numerator, I still have a 4, and I have a y plus 4, so I'm going to multiply. I'm going to do 4y plus 16 over, and then I just have a y plus 2 left in the denominator. So remember, as tempting as it is to try to cancel out little bits and pieces, you absolutely cannot. Okay, and then it says, under what conditions is the expression defined? When you are trying to answer this question right here, what you're going to figure out is when the denominator is equal to 0. Okay, so any time that the denominator would be equal to 0, it would be undefined. Okay, so if we look at this factored version right here, if I set this equal to 0, I just get y equals 0. So I'm going to say y can't equal, it can't equal 0. If I set y minus 3 equal to 0, I get 3. And if I set y plus 2 equal to 0, I get negative 2. So the original one, before you cancel anything out, you set the denominator equal to 0. All right, so this is my expression as long as none of these things hold. Okay, next, let's do some more factoring and simplifying with this next one. So the 2z is factored already. The z plus 5 is factored. I do have to factor this thing down though. All right, so I'm looking for what's going to multiply to a negative 8. So I start with z and z. We want to know what's going to multiply to a negative 8 and add to a positive 2. That would be a positive 4 times a negative 2. All right, if I FOIL this out, my positive 4 times a negative 2 gives me negative 8, but when I add outside inside, I get a positive 2. Okay, now there's actually nothing else to factor in the denominator. Okay, so that's step 1, factor everything. Anything that can be simplified down, do it. Step 2, eliminate common factors. So if I look, I've got a z minus 2 over z minus 2. They're exactly the same, so I can cancel them. I have a z plus 5 and a z plus 5, so I can cancel those. Now remember, this z is part of a package deal, so I can't cancel it with this z, I can't cancel it with this z, I just leave it the way it is. So now I'm going to kind of redistribute. So I've got 2z and a z plus 4, so I'm going to do 2z squared plus 8z. All I'm doing is I'm distributing the 2z. And then in the denominator, I have a z minus 1. So don't try to cancel anything that would be illegal. Now for writing what I can't be equal to, I write z cannot equal, and then anything that would make this equal to 0. So if I set z minus 1 equal to 0, I know I can't plug in 1. If I set z plus 5 equal to 0, I know I can't plug in negative 5. And if I set z minus 2 equal to 0, I know I can't plug in 2. So those are all the places where my expression would be undefined. Okay, so it says, under what conditions is it defined? As long as I use anything but these numbers, it's defined. Okay, this one, example 2, is a standardized test example. So I'm going to run you through what like a typical strategy would look like if you were taking this on the ACT. Okay, so for what values is this undefined? Remember, undefined means the denominator would be equal to 0. So take a look at my denominator. First of all, negative 6 is never going to be equal to 0. It's negative 6, so we don't have to worry about that. But then my x squared minus 3x minus 10. If I were to set that equal to 0 and solve, I would have two different pieces. I would come up with two different factors, one factor here and one factor here. The important part of that is that I would have two factors. Okay? Not three factors, not three factors, not three factors, but two. So just by the process of elimination, I actually got right down to my answer, you know, what it's supposed to be. Let's just double check real quick. If I took x squared minus 3x minus 10 and set it equal to 0, I would factor this left-hand side. So I've got my two pieces. I start with x and x, just like always. And then I want to multiply to negative 10 and add to negative 3. So that would be a negative 5 and a positive 2. So if I set these two pieces equal to 0, that's exactly what I would get right here. All right, but make sure you're using some different strategies when you're doing standardized test stuff. Okay, let's look at the stuff on the back. There's one more little technique that I can give you. Sometimes you can factor out a negative 1 when you're factoring if something just doesn't quite match. So in the numerator, we're reminded of a method called the Gcf method. See how they both have a z? I can actually factor out a copy of z, and then I'm left with an x minus 4. In the denominator, I have a z squared, which is really just two copies of z multiplied together. And then here I have a 4 minus x, which is very, very similar to this. So what I'm going to do is I'm going to factor out, so times, I'm going to factor out a negative 1. And if I divide these both by negative 1, I have a negative 4 plus x. So you'll see what happens in the next stage. See, these are technically exactly the same. I have a positive x minus 4, and then I have a negative 4 plus x. Those are actually identical, so I can cancel them out. Okay, and then I have one copy of z that can cancel out with one of these copies of z, and I'm still left with one. Okay, so what I end up with is negative 1. I'm actually going to write the negative 1 in the numerator. It looks better in the numerator. You don't want to put it in the denominator. That is my final answer. But you have to make sure you include the fact that z cannot equal 0. And then if I set this equal to 0, it tells me that x cannot equal 4. So as long as I don't try to plug in either of those values, I'll be good. Okay, this one. This one. In the numerator, both of those pieces have an AB, so I'm going to factor out an AB. And I'll be left with b minus 5. And then in the denominator, this piece right here is the exact opposite of this piece. So I'm going to leave the 5 plus b exactly the way it is. But then with this next piece, I'm going to factor out a negative 1. And then I'll be left with negative 5 plus b. So remember, these two are technically identical. I just have them written in different orders. So I can cancel those out. It wasn't very dark. There we go. Okay, now I'm just going to flip the negative 1 up to the numerator like I did before. So negative ab over 5 plus b. Okay, so that is my simplified answer. And then if I look back here at the original, b can't be equal to negative 5 or positive 5. As long as I don't try to plug one of those two values in, I'm good. Okay, so that's simplifying. All I did so far was I just simplified some expressions down. Now I'm going to move into multiplication and division. Okay, so multiplying, it's pretty simple. It's just like multiplying two rational numbers together. You multiply the numerators out and you multiply the denominators out. And then dividing, you've done this before with rational numbers as well. When you're dividing rational expressions, what you do is you multiply by the reciprocal. I'm sorry, whoops, this should say divisor. Multiply by the reciprocal of the divisor. Sorry about that, I started to write denominator. Okay, so for example, if I have a over b, let's say that's one rational expression, if I'm dividing it by c over d, it's the same to do this. I keep the first one. I keep the a over b just the way it is, but then I'm going to multiply by the reciprocal, which means I'm going to multiply by this piece right here, but just flipped. So instead of c over d, d over c. So it's like that flip the guy and multiply that you guys have heard before. Okay, so now we're going to take a look at a couple different types of examples. We're going to look at monomial examples and then polynomial examples. Okay, so starting, I'm actually going to try to get, ignore me here, I'm going to try to get nice and zoomed in. There we go. So you can actually see what I'm doing. So I like to cancel everything out I can first and then multiply, and you'll see why that's slightly beneficial. So if we're looking at this first one, for instance, start to look at the numbers first. Like the 14 and the 21 have a 7 in common. So you can factor out a 7. Like 14 without the 7, you're left with 2. 21 without the 7, you're left with 3. And then like the 12 over 8, they have a common 4. So if I divide 12 by 4, I'm left with 3. If I divide 8 by 4, I'm left with 2. And then if you look at the numbers again, here I have a 3 over 3, and those will cancel each other out. Here I have a 2 over 2, and those will cancel each other out. Okay, so I took care of the numbers. Let's take a look at some of the variables. All right, so looking at like b's, for instance, you can see the b's cancel right out. B cancels with B, and then like D, I have D squared over D, so I can cancel out one copy, and I'll be left with one copy right there. A's, I can cancel out one copy, and I'll be left with one copy right here. And then C squareds, I have C cubed over C squared, I can cancel out two copies, and I'll be left with one copy right here. So if you look closely at the denominator, everything has canceled from the denominator. And then in the numerator, I still have an A a C, and a D. And that's my entire answer. Once everything is canceled out, that's all I have left. Okay, let's do the same thing in the part B, except part B is division. So I'm going to rewrite it first as multiplication. So I take the first piece exactly the way it's written. Nothing changes about that first part. And then remember, you flip the guy and multiply. So you multiply by the reciprocal. Okay, so we've got that set up, so now I'm going to do the same thing. I'm going to look for anything common that I can cancel out. So starting with the numbers 16 and 24 are both multiples of 8. So if I divide by 8, I'm left with 2 here and 3 here. And then 7 and 21 are both multiples of 7. So if I divide by 7, I have 1. Divide by 7 here, I have 3. Now these 3's don't cancel. You have to have one copy in the numerator and one copy in the denominator for them to cancel. Let's look at m's. Here I have one copy of m, which cancels with one copy of m here, and I'm left with 2 copies. T, there's actually nothing to cancel with. For a's, I have 2 copies in the numerator, 4 copies in the denominator. So these will cancel. I'll lose 2 of these copies, and I'll have 2 left. And then b's, I have b squared, b cubed. I can cancel out 2 copies, and I'll be left with 1 copy in the denominator. Okay, so in the numerator, I have a 2 times 1, which is just 2. And then I have a t squared. And then in the denominator, I have a 3 times 3, which is 9. I have an a squared, a b, and an m squared. Okay, so that is my slightly less complicated answer for that one. Okay, so let's move on to the last page. On the last page, we're going to be doing a little bit of factoring before we multiply and divide. Okay, so if we look at example 5, our first step is to factor. Lots of factoring. So this first one, for instance, 8x minus 20, all I have to do, oops, this is being weird. All I have to do is take out a GCF. So the GCF is 4, and then I'm left with a 2x minus 5. Let's look in the denominator. In the denominator, I have x squared plus 2x minus 35. So let's set up our factors first. I know I'm going to have x times x. And then for the numbers, I want to multiply to a negative 35 and add to a positive 2. So that would be a positive 7 and a negative 5. So test it out. I multiply them, I get negative 35. I add them, and I get 2. Then times this next piece, x squared minus 7x plus 10. I know I have 2 factors. I can start with x and x. When I multiply, I get 10. When I add, I get a negative 7. So if they multiply to give me something positive but add to something negative, I know they're both negative. So 10 is 5 times 2. And when I add those together, I get a negative 7. And then in the denominator, I can factor out a 4. And then I'm left with x squared minus 4. And then this, I'm hoping we recognize that. That is the difference of squares. So I can write that as x minus 2, x plus 2. So lots of factoring skills. I would highly recommend coming to see me or looking back over some of the factoring stuff if this isn't easy to you. Because if this isn't easy to you, the rest of the chapter is going to be a huge challenge. Okay? So the next step is to just kind of cancel out everything you can before you multiply. So for instance, I have x minus 5s, one in the numerator, one in the denominator. I have x minus 2s. It doesn't matter if you come from this numerator and this denominator, or this numerator and this denominator. As long as you have 2 copies, one in one numerator and one in one of the denominators, you're good. I also have 4s that I can cancel. And it looks like that's it. So for the denominator, you don't have to FOIL that back out. I would actually recommend probably not doing it. I would just leave it as x plus 7, x plus 2. And then that's your final answer, the simplified down version. Okay, for this one, we are going to first write it out as division. So I've got the x squared. Actually, you know what? Let's just start factoring right now. So the x squared minus 9 plus 20. I've got x and x. We want to multiply to positive 20 and add to negative 9. That would be a negative 4 and a negative 5. Then in the denominator, I can factor this one down too. We start with x and x. That's where I get my x squared. I want to multiply to 21 and add to 10. That would be a positive 7 and a positive 3. Okay, now times. Here's where the division comes in. I'm going to flip the guy and multiply. So now this is going to be my numerator, the 6x plus 42. I can factor out a 6, and I'm left with an x plus 7. And then again, since I flipped, this is now my denominator. So I have two factors. I want to multiply to negative 12 and add to negative 1. That would be a negative 4 and a positive 3. Okay, so I'm totally factored. I'm ready to cancel and then combine things back up. So I have an x minus 4 over x minus 4. I have an x plus 7 over x plus 7. And that's it. People get very tempted to cancel these out. Just because you see 2 of something doesn't mean you cancel them. You have to have 1 in the numerator and 1 in the denominator. So I have a 6 times an x minus 5. That's 6x minus 30. And then in the denominator, I can write this as an x plus 3 quantity squared because I have 2 of them. All right. The last thing we're looking at is simplifying complex fractions, which is pretty much what we've been doing before. A complex fraction, the book gives you like a very in-depth definition. I'm going to give you the simplest definition I can. A complex fraction is a fraction of fractions. So it is a fraction that has a fraction as a numerator and a fraction as the denominator. So if you look here, like this is the numerator, and that's a fraction, and then this is the denominator. So the way that you solve these, the way you simplify them, is you rewrite it as division. All right, so that's what we're going to do. So we're going to start with, technically the numerator is just like the first two. And then since we've got this piece right here divided by this piece right here. So that's how I'm going to write it. I'm going to write divided by, and then I'm going to write the denominator technically. Okay, so basically the only difference between what we were doing up above and these is that we have to rewrite it first. And then we can start factoring and canceling and all sorts of other fun things like that. So x minus 2 squared, I'm going to write it as x minus 2x minus 2. In the denominator, I have that 2 out front, and then I'm going to start to factor down. I've got x and x. For this one, I want to multiply to positive 4 and add to negative 5. So it's going to be a negative 4 and a negative 1. And then I flip the guy and multiply. So now this is my numerator. I can factor out a 2, and I have a 2x minus 5 in parentheses. And then this is my denominator, again, since I flipped it, and that's the difference of squares. It's x minus 2x plus 2. Okay, so I write it out like that. Before I combine everything up, I'm going to make sure I cancel out everything that I can. So I've got x minus 2's that can cancel. I've got 2's, just 2's that can cancel. That actually looks like it's it. This one is a little messy. There wasn't very much that canceled out. So in the numerator, I have an x minus 2 and a 2x minus 5 that didn't cancel. And in the denominator, I have 3 terms. Ooh, that's messy. Okay, so that, unfortunately, is as simplified as that one will become. Okay, on to the last one. Last one, we rewrite it as division. So I start with x squared minus y squared over y squared minus 49. It's kind of like the numerator of this overall fraction. And then divided by the denominator, which is y minus x over y plus 7. Okay, so I rewrite it as division. That's the only thing that separates me from what I was doing on the top half of the page. And then I'm going to start to factor so I can cancel. So x squared minus y squared is actually the difference of squares. So I write it as x minus yx plus y. This denominator, the y squared minus 49, is also the difference of squares. It's y plus 7, y minus 7. And then times, now I flip this. I write it as the reciprocal. So the y plus 7 becomes my numerator, and the y minus x becomes my denominator. Okay, so finally I cancel. I've got copies of y plus 7 that will cancel out. Now these two things, this one right here and this one right here, they're not exactly the same, but they're opposites of each other. All right, so when I reduce down opposites, I just end up being left with a negative 1. So if I cancel these out, you have to remember to leave a negative 1 in its place. That's because they're opposites. It's like negative 2 and positive 2 are opposites. If I divided negative 2 by positive 2, I'd be left with negative 1. Or like negative 10 and positive 10 are opposites. If I divided negative 10 by positive 10, I'd be left with a negative 1. So because these are perfect opposites of each other, when I cancel them out, I'm left with a negative 1. So I have a negative 1 times this. So a negative x minus y, and then over a y minus 7. All right, so that is my final simplified answer. All right, so hopefully you guys are doing okay with the factoring. Hopefully that's just kind of second nature. So that is it.